This is video on problems on kinematics of rigid body. Now we are going to use instantaneous center method, and you need to look at the basic two videos before you get hang of the problems. There are only 10 minutes videos, so you may want to have a look at them. Now, we have following type of problems. That is, there will be a problem with single link, means single member. Then there will be double link, there will be two members. There will be triple link, there will be three members. And there will be single link along with a cylinder. And then there could be miscellaneous problems. These type govern all the possible problems for the Mumbai University. So we are going to do one by one, and in this video we'll cover single link and double link problems. The remaining will come up in the next videos. Now, what we need is our good old sine rule. Now, you all must be knowing it, but just for the sake of revision, sine rule is like this. If there is a triangle ABC with lengths L1, L2, L3 and included angles alpha, beta, gamma, then this holds. That is L1, the length L1 upon sine of opposite angle, sine beta, is always equal to length L2 upon opposite angle sine gamma is equal to length L3 upon opposite angle sine alpha. Now this is going to be handy for solving equation, and our governing equation for this is V is equal to R omega, because we are going to look at instantaneous center and then we are going to find out velocity using formula R omega. Now, let's say we have first problem like this. There is a ladder which is sliding. Okay, so A moves towards right and B goes down, and what is given to you is velocity of point A is 4 meters per second as shown. And what is asked is find velocity of point B and angular velocity of ladder. Because see, when ladder slides, ladder is going to rotate. So it has some angular velocity and we need to find that. Now, our first job is to find instantaneous center. And if you are referred to the earlier videos, you will know that instantaneous center can be found by drawing perpendiculars to two velocity directions on the body. So to VA, which surely is going to be along x-axis, and VB, which surely is going to be along negative y-axis. We draw perpendicular. Wherever this perpendicular meet, that's instantaneous center for ladder AB. Now mind you, instantaneous center, as I already mentioned, can be outside the body. That's not the issue. Now we have to settle the geometry for this triangle IAB. So it follows that the angles involved are 30, 60 and 90, can be just seen from the geometry. And we have this basic equation. Because I is instantaneous center for AB, velocity of A is given by distance IA into omega AB, that is angular velocity of AB. And VB will be similarly given by distance IB into omega AB. Why? Because see, velocity of any point on a rigid body has two values, one that of reference, other due to rotation, that is R omega. Reference is I, the instantaneous center, whose velocity is 0. Therefore, each point is going with reference to the instantaneous center is going to have only one velocity, and that is distance into omega. So we have expression for VA and VB. Now, we use the sine rule for triangle IAB, and if I do that, we get IA upon opposite angle sine, that is I upon sine 30, IB upon sine 60 and AB upon sine 90. Distance AB is given to you, and therefore we can work out IA as 3 and IB is 5.196. So this information we will keep it here, and Let's use VA is equal to IA into omega AB. IA we have worked out as 3 and VA is given as 4. So that follows one answer. Omega AB is 1.33 radians per second. Now, let's use VB is equal to IB omega AB. IB is known as 5.196. I put it here. Omega AB we just worked out 1.333 and therefore VB is 6.926. So we have managed to find angular velocity of the ladder and also the downward velocity of point B, VB, which is 6.926 meters per second, of course, because the units are in meters. So this is a typical solution for a single link problem. Now suppose you have two link problem like this. See what the problem, what's happening. At sea there is some sort of roller by which it can move in a horizontal direction. Point C. A is hinged and B is internal hinge by which A, B and B, C are connected at B. Now we have been given velocity of point C as 3 meter per second and we are asked to find velocity of point B and angular velocities of link AB and AC. Now see how we go about it. First of all, from previous videos if you have watched, you know that instantaneous center for AB is A and instantaneous center for link BC can be obtained by drawing perpendicular directions to these blue velocities. Now you see at B, first thing it is on AB. A is instantaneous center, so B's velocity has to be perpendicular to AB and that's how it is shown. Now I look at BC. I find that on BC I know two velocity directions. I draw perpendicular to these directions. I get my instantaneous center. Then let's settle the geometry. 45, 45, 90 we get, and then for link AB, VA is 0 and VB is AB into omega AB. Similarly, for link BC, VC is IC distance into omega BC and VB is IB into omega BC. And our sine rule, if applied to triangle IABC, it will be IB upon sine 45 is equal to IC upon sine 90 is equal to BC upon sine 45. Therefore, we can work out IC from this as 0.566 meters and we can use it because BC is IC into omega BC. You substitute IC, you get your omega BC, which is one of the things which was asked. Now we use VB is equal to IB omega BC. IB is known, given in fact as 0.4. Omega BC we just worked out, so we get VB, which is the second answer. And now we use for link AB, VB as distance AB into omega AB. VB as known and distance AB is given as 0.4. So omega AB works out to 5.303. And directions anticlockwise and clockwise can be seen from the way the links move. C goes towards right. Obviously, BC will go anti-clockwise and AB will go clockwise. So this was about the two link problems. Thank you. We will continue these problems in the next video.